Alright guys, can you do question 1 please? Can you do question 1 from sheet 4? Sheet 4, question 1 guys. Guys. Can you guys do question 1 please from sheet 4? Can you guys do question 1 please? All right, guys. I know many of you have already done question 1. So could you guys listen, please, which you haven't done. I mean, this is really an easy question, guys. Sorry, what am I doing? All right. So you guys listening or what? This is the likelihood function for the likelihood function for the question 1, which you can simplify to this to this, right? The next step is to take the log. So you're taking the log of this, it becomes all right. This is are you guys with me or what? You got this right, yeah? It's too easy, right? Now the next step is to take the derivative with respect to theta. There's no partial derivative here because there's only one parameter, right? So this is the derivative with respect to theta, and set this to 0, solve for theta, you get theta hat equal to minus n this is the solution for theta. Now to make sure that this is an MLE, what do you need to do, guys? You need to do find the second order partial derivative with respect to theta, which is minus n by theta squared, which is of course a negative number. So since the second derivative is negative, it follows that theta hat given by this is indeed an MLE. All right, so that completes. I mean, that completes question 1, guys. You know, it's not difficult, is it, guys? It's easy, right? Then you do question 2, guys. Now. You're all set. No, you already done. You already done question 1. Good. Can you do the next one, please? Yeah. You okay? Okay, so you done question 2? Can you do that? You guys okay? Yeah. Alright, guys, listen. Let's see how we can do question 2, right? Okay, question 2 is I'm trying to remember the name of the question. Alright, here we are. Question 2. Alright, so this is the likelihood function, guys. Now you should simplify this. What do you get, guys? You get what? You get this. Is this what you got, guys? Yeah? This is the simplified form of the likelihood. Take the log likelihood. You get 2n log theta plus the sum of this plus this, guys. Alright? So this is the log of the likelihood. The next step is to differentiate the log likelihood with respect to theta. So you get 2n by theta minus this. When I set this to 0 and solve for theta, you get theta hat. You get theta hat equal to 2n divided by the sum of xi, which is 2 divided by the sample mean. Alright, now to make sure that this is a MLE, you need to do the second order derivative. Alright, and this will become this, right? And this is obviously a negative number. So since the second order derivative is negative, we can conclude that the theta hat is an MLE. It's easy, right? Any questions, guys? Question 3, guys, now. Guys, do question 3, please. Alright guys, we want to find the MLE of the probability that x is less than 0. And we are told that x is a normal variable with parameters mu and 1. So the first thing you need to do is to work out what the probability that x is less than 0 is. Yeah? You guys listen to me, guys. This is question 3, guys. I'm trying to help you to show it. So I know some of you have already done it, guys. I know. So the first thing you want to do is to work out the probability that a normal variable with these parameters is less than 0. Right? Now how do you work this out, guys? To do this, you use the standard trick. The standard method is guys, what have I done here, guys? What have I done here? I have subtracted mu on the left hand side and the same on the right hand side. Now, yeah, this is what is known as standardization, guys. This guy here will become the standard normal variable less than minus mu. Right? Now you know this guy. Yeah, this is simply the CDF phi at minus mu. Remember, phi denotes the is the CDF of standard normal. Okay. So to find the ML, the question. Okay, returning to the question, guys. The question is to find the MLE of this, right? And this, therefore, is equal to phi at minus mu hat. Now mu hat is the MLE for mu. Now if you guys were here in the lecture today, I'm sure you were in the lecture, but in the lecture last Wednesday, I showed you that if you have a sample from a normal distribution with parameter mu, complete the blank. What do you think mu hat will be? I did this question last Wednesday, guys, in the lecture. I know you have better. I'm an old man like me. I have a very old brain. Yeah, I thought you. What is the estimator for mu?
The average of x?
Yeah, exactly. It's the average of the x's. I mean, if you look back in the notes, see. If you look at my handwritten notes for 23rd, which is the last Wednesday, yeah, is it? I think it's the last Wednesday. Yeah. If you look at the handwritten notes for this, you will see this, that mu hat is equal to x bar, right? Now x bar, you can work it out. You can work out x bar from the data that is given to you. So it will be 1.466 plus 1.791 plus 1.353 up to the last one will be minus 0.237, right? And divide all these numbers. Divide numbers by 8. 8 is the number of observations. So you have to work this out, guys. Work this out, right? And then once you get, I don't have a calculator, so you just work it out, and whatever the number that you get here, you sub it in here, and that's the answer. All right? Is that clear, guys? You okay, guys? That's known as standardization. If you subtract the mean will become 0. Yeah. This is known as, this is the standard normal variable. 0 mean variation. Yeah.
就刚才那个头发是把我的笔挂着，然后在我衣服上画。
All right, guys. Any questions on ray trace? All right, now, are you okay with this, guys, or no? Yes, no? All right, now, I'm going to make a sidetrack because, remember, these 4 questions, 4, 5, and 7, 4, 5, 6, and 7, are for next week's. Now, what I'm going to do in the remaining time is because remember from last week, I did not do some questions last week. You guys remember that or not?
Yeah.
I didn't do the question. I think it was question 6. Was it 5, 6, and 7? You had the sheet last week? No.
4, 6, 7. Oh, 5, 6, 7. 是的吗？我没有。
You should look at, guys, this is question 5, sheet 3. This is sheet 3. Sheet 3 is last week's sheet. I think the question was this. This question, I think I did this question in the lectures, guys. I don't know which lecture it was. If you look back in, guys, if you look back in one of the lectures, you will see I did this question, guys. I can't remember the exact lecture I did this, but you should go through the previous podcast. I did this question, that is, when you have a random sample from a geometric distribution, find the MLE for P. Yeah, I did this. So I'm gonna move on to question 6 now, guys. Question 6 was a tricky one, so I will do it in full. So I'm not gonna cheat you guys. So I will do question 6. All right, could you guys listen, please? This is question. So I'm gonna do question 6. I'm gonna do question 6. I know several of you had problems doing this question last week, so let me explain to you now, guys. I think some of you had problems with this question, right? We had n observations from a binomial with, random variable with these parameters. Now. A binomial random variable with parameters 2 and p has this PMF, right? And the possible values for x can be either 0 or 1 or 2, right? So the probability that x equal to 0 is this, and the probability that x equal to 1 is this, and the probability that x equal to 2 is this. All right? Are you with me so far, guys? Are you listening to me or what, guys? I mean, this is one of the questions I think many of you had problems with doing last week, so that's why I'm doing it this week, guys. Yeah? All right? All right. The question said that there are capital N observations, right, from this random variable, and this variable can only take 3 different values: 0, 1, or 2. 0 with this probability, 1 with this probability, 2 with this probability. Now the question also said the following. It said that there are n0 observations having x equal to 0. And it also said there are n1 observations having x equal to 1. And it also said there are n2 observations having x equal to 2. So the total number, guys, which is this plus this plus this, is equal to capital N, right? The total number. There are capital N observations, right? Out of the capital N, little n0 observations have x equal to 0. Little n1 have x equal to 1. And little n2 have x equal to 2, right? And that's what the question said. Now the question was, the ultimate question was to find the MLE of P. Now to find the MLE of P, the first thing you need to do is to write down the likelihood. Alright, now we know that this is the probability that a single x equal to 0. This is the probability that a single x equal to 1. Now we know that, look, according to what I have written here, guys, there are n0 observations with x equal to 0. But this is the probability that a single x equal to 0. So what's the probability that there are n0 x's? There are n0 with x equal to 0. You need to...
How?
You understand what I've done, guys? Huh?
Yeah.
Yes? This is the probability that a single x equal to 0. So, but there are n0 observations with x equal to 0. So it's this. And similarly this, right? So if you now put in the numbers, guys, this is what you get. Okay? Now simplify this, guys. We get this is what you get, right? So this is the likelihood function. So the most difficult part of this question, I think the thing that troubled many of you last week is to get this right. You should get this part correct, right? You should get this part correct, and the rest of the question is easy, right? You know what I'm saying? The difficult part of this question is to get this part right. Just to go through this and get this right. Right? Once you've done this, then you know what to do after this. All right. The next step is to find the log likelihood, which is All right, this is the log likelihood, and the next step is to differentiate the log likelihood with respect to p. You get this, guys, and then you set this to 0, guys, and solve this equation for p. You will get p hat equal to n1 plus 2n2 divided by 2 capital N. I think this is what you will get. Now finally, to make sure that this is an MLE, you know what to do, guys. To make sure that this guy here is an MLE, you find the second order derivative, which is this, and this is of course less than 0 because you have minus minus, so it must be negative, right? All right, therefore the final answer is that p hat is an MLE, right? All right, so that completes question 6, guys. Is that clear, or any questions from you? I know this was a tricky question last week, but I think some of you got it right, or maybe most of you, I don't know. Does it make sense with you guys? Yes. Right, now that was one question I did not do. The next question I did not do last week, guys. The other question I did not do last week is question 7. Oh man. Are you all finished with this, guys? Can I remove this? Yeah? Alright, okay. So the other question I did not do last week, guys, is question 7. Question 7, sheet, this is sheet 3 or sheet 3? Yeah, sheet 3. Now it talks about do you guys have this question in front of you? This is question 7, guys, from last week, sheet 3. Now it talks about the number of cereal boxes bought by mean. I didn't mean mean, I meant. Sorry, guys. All right. And according to that question, I mean, it's obvious from the question, right, that X has the, what distribution will it have? It will have the binomial distribution with parameters 70 and P, right? P is the probability that a cereal box bought by a man. Okay, all right. So x is the variable, that is the number of purchases by men. Will have a binomial distribution with parameters 70 and P. 70 is the total number of purchases, and out of that 58 were bought by men. So what is the probability of that, guys? If you have 70 purchases and 58 are bought by men, what probability will that be, guys? Huh? Come on. You 70 choose 58, P I'm sure you guys remember this from ages ago. This is the binomial probability mass function, right? Yeah. All right. So that completes part 1 of the question. Now part 2 was to find the MLE for P. To find the MLE, just we take the log. So it's the log of this guy here. Alright, and then you take the derivative of the log likelihood with respect to P, which will be 58 by P minus 12 1 minus P. Set this to 0, guys. If you solve this equation for P, you will get P hat equal to 58 by 70. Now to make sure that this is an MLE, you need to do the second order derivative, which will be minus 58 by P squared come on, guys, don't be tired, guys. Alright, this is the second order derivative, which is obviously negative because you have minus minus, right? So hence P hat equal to 58 by 70 is an MLE. Alright, this is part 2. Now the part 3, there's one more part, guys. There's one more part before we finish for today. For part 3, the question was to excuse me, guys. The question was to what is the MLE for P when P is between half and 2/3? That was the question. Yeah? You guys the sheet in front of you or what? Yeah. What is the MLE for P when P is between half and 2/3? Now how do we answer that question? Part 3.
Sketch the graph.
Yeah. This is where you need to use the. Remember the approach I talked about last week, guys, where you use the restricted domain approach. Yeah.
Yeah.
Yeah. That's this. So this is where you need to do that, guys. This is where your graphing skills come in. My graphing skills are not really good. So what I'm going to do is, guys, I'm going to plot L of P. L of P is the likelihood function, which is this one here. This function here is L of P. Right, so I'm going to plot L of P versus P over the interval from 0 to 1. So it's 0 here, 1 here. Suppose your half is here. Suppose your 2/3 is here somewhere, right? Now, if you do the graph, I'm not gonna. Don't ask me to teach you how to graph. I'm sure you guys are better experts than me on graphing things. Okay, but if you draw a graph of it, it will look something like this. It will look something like this, guys. Yeah, the graph will look, I'm not a good, will look something like this, and it will be, the 2/3 will be somewhere here, your half will be somewhere here, right? And this largest point here, this is the largest point of the graph, will correspond to 58 by 70. Okay. Now the question here is now let's try to answer the question, guys. The question is if P is between half and if P is in the interval from this point to this point, in other words, this point to this point, from this point to this point, what is the largest point of the graph? What is the largest value of the graph over this interval? Yeah, it's at this point, right? And the corresponding P is 2/3. Alright, so the answer is P hat equal to 2/3. Alright? Is that clear, guys? Yes?
But you missed the one, the 95.
Yeah, that you don't need to do.
I don't need.
You don't need to do that, guys. Because that's off the syllabus this year. Is that clear to all of you guys?
Yes.
Any more questions? So the last 4 questions from sheet 4 are from next week, guys. Alright, is that clear? The last 4. Guys, shh. These question 4, 5, 6, and 7. These 4 questions are for next week, okay? For the example classes next week, you will do these 4 questions. Right? Has everybody signed the attendance sheet, guys? Anybody? Alright, good.
而且这中间可以穿插小时。今年只有
In this case, we only have one observation. We have only one observation. 58 purchases by 10. So the likelihood, in this case, the likelihood is the same as what because we only have one observation. Yeah, so in this case, there's only one data, right? One data point. So in such cases, the likelihood is the same as the density function.
这样，他这个 lambda 之后，他这个人就调回到正模式，所以说之后他用的现在这个 alpha 现在用
This one, which one? No, this is not the same as this one. Yeah.
但是我开过，他有一个开过，他在
We have only one observation from the binomial variable parameters 7b and p.
天哪，我那种
So the likelihood is the same as the PML binomial parameters 7b
你有些课没合适吗？
Because it says there are 0.58 purchases from 70.
One
data. One observation. Yeah.
啊？这个不是否定式这种。比如说小于否定者，小于正数，就是它小于否定者逗号。终于在这儿了。够不够？不要这么恶毒，是吧？是吗？我觉得应该不在。还有7个人，你知道吗？人切开够。我操！
你知道我听说什么？我还亲我人。我说1年我15的，我15的。
真的，不去哪儿学习啊？这个？
吃完之后去
太远了吧？
太远了吧？
然后司机这么远。
太远了吧？
哎，这个，我有手机吗？
哎，我明天比较考试啊。
对啊，我明天。
是
你们都不希望啊？你什么？你什么？
我操！明天这么多的话，没亲了。
有一个人说看脸，有一个老姐，那个采访的人，采访了6人，没有晒成这么好看的采访对象，对，然后是老交工，对，有位老姐说，